In this lecture, presented by www.free-academy.com, we're going to be practicing the definition of the derivative by doing problem 12 out of the textbook. Now, I've modified this slightly. In the textbook, this was f of x was equal to 2x to the third plus 1, although that's an unnecessary amount of algebra and it's not any more illustrative, so I'm going to do 2x squared plus 1. So after we find the derivative for f of x, then we need to find the tangent point at x equals negative 1. So to solve the derivative, we're going to need two different pieces. We need f of x, and then we need f of x plus h. We already have f of x, so now let's find f of x plus h, which is just a matter of putting x plus h anywhere you see x in the original equation. So we replaced x with x plus h, and then we need to solve this out algebraically. And if you do the math, you can find that this is 2x squared plus 4xh plus h squared plus 1. Sorry, this will be 2h squared plus 1. Plus 2h squared plus 1. This is element B. So we have f of x, we have f of x plus h. Let's plug it into our equation and then evaluate. So I have the limit as h goes to 0 of 2x squared plus 4xh plus 2h squared plus 1. This will be minus our f of x, which is, I can probably ditch the parenthesis, 2x squared, and then minus 1. And that's distributing out the negative right away. This will all be divided by h. So now that we've set up our formula, let's solve to get rid of h from the denominator so we can evaluate the limit. We can immediately see that 2x squared will cancel out with minus 2x squared, and then 1 will cancel out with negative 1. So this will be equal to the limit as h approaches 0 of 4xh plus 2h squared divided by h. We'll factor an h out of the numerator and then cancel with the denominator. And this is going to give us the limit as h approaches 0 of 4x plus 2h. Now you can apply the limit, and this is equal to 4x, which is equal to the derivative. Now, the second part of this problem is going to be to find the tangent line at x equals negative 1. To find the tangent line, we need two different things. Let me clear out this sheet here. F prime of x equals 4x, and tangent line at x equals negative 1. To find the tangent line, we need the slope, and we need 1 point. And once we have a slope and a point, we can put this into point-slope form, and then we'll have the equation of the tangent line. Now, something that should be very familiar to you at this point, and make sure you practice it if it's not, is that the derivative of a function is an equation for the slope of that function at any single point. So if we find f prime of negative 1, that's the slope of negative 1. So f prime of negative 1 is equal to 4 times negative 1, putting 1 in for x. This is equal to negative 4. And that's equal to the slope of the tangent line at that particular point. So the slope equals negative 4. So we have the slope. How do we get a point? Well, that's pretty easy. Let's take f of x equals 2x squared plus 1. And let's find it for x equals negative 1. this will be equal to 2 times negative 1 squared plus 1, which is equal to 3. So now at the point negative 1, 3, and the slope equals negative 4. Put this into point slope form, and you get y minus 3 equals negative 4, x minus negative 1. And there you have the derivative and the equation of the tangent line.